Yes, good morning. I am looking forward to the combined Q&A afterwards. When I was in Britain, I learned the British had a kind of approach to questions and answers a little different than ours. I was in a grad school seminar. My first year in Britain, a little wet behind the ears, American grad student. There was a distinguished professor of Kantian philosophy that came to our department. He was giving this extraordinary lecture. I asked a question in the middle because he was talking about some things in Kant's philosophy that I had never heard of. And I asked him if there was a bibliographical source, a book that I could read about that aspect of Kant's philosophy. I said, I'd never heard of that. And afterwards, my supervisor took me aside and said, Meyer, he said, I know in the States you've learned that the only stupid question is the one you didn't ask. And then he said, it's different here. And he said, if you're to succeed, you must learn to bluff. He said, everyone here is bluffing. If you're to succeed, you must learn to bluff too. So in future, if you have a question that reveals ignorance, please come ask me privately, he said. We will have an extended Q&A. I'm going to kind of reveal the surprise right now. We have the astronomer Guillermo Gonzalez here with us, who is the co-author of Privileged Planet, and one of the real luminaries in the intelligent design movement. He's going to help Jay and me field questions on the subject of the next two lectures. I'm going to be talking about the beginning of the universe, and Jay's going to be, and a little bit about the fine-tuning that you heard about from Eric, and then I'm going to pass the baton to Jay, and he'll be talking more about the fine-tuning and the privileged planet hypothesis, and then we're going to bring Guillermo up, and we will have this extended Q&A, and it will be American rules. No stupid questions, okay? All questions are valid. All right, I'd like to begin by talking a little bit more about this media blackout that Eric Metaxas was talking about. And I'm having a little bit of difficulty, as it almost always happens, with the PowerPoint. There we go. Richard Dawkins is one of those popularizers that we all encounter in that cultural flood of information that Eric was talking about. Here's a quotation that has influenced Dawkins and many of his so-called scientific atheists, or the new atheist movement. They started publishing books in 2007, and they've been million sellers. And this is a quote from one of those books. He says, the universe we observe has precisely the properties we should expect if there is at bottom no design, no purpose, no evil, no good, nothing but blind, pitiless indifference. You may remember that one of his first best-selling books was The Blind Watchmaker. And Dawkins' argument runs like this. He says that science properly understood undermines belief in God. Why? Because before Darwin, we knew that the strongest argument for the existence of God was always the evidence of design in nature. But when Darwin came along, we were able to explain that appearance of design, that illusion of design, as the result of a blind, undirected process called natural selection acting on random variations. And now biologists would talk about natural selection also acting on random mutations. But that undirected process explains the appearance or illusion of design. So now we know there's no real design, only an illusion of design, and therefore there's no designer, and if there's no designer, there's no God. And so he says if you want to believe in God, you're still free to do so as a sort of subjective superstition. He calls it the God delusion, but there's no objective evidence for the reality of God. And that's one of those really powerful cultural messages. And I know, having been a professor, this really profoundly has affected a lot of students, people in that pre, post, and college age years when most of us form our worldviews. In fact, there's a lot of polling data on this, that young people are losing their faith in droves as they go to university. Many of them do come back later, many don't. But science and the perception that there is, quote, no scientific evidence for God is one of the really powerful reasons for that loss. And a lot of that is coming from this cultural messaging from these folks we call the new atheists, and also the professorate who has been influenced for over a century by the rise of what we call scientific materialism, a worldview about which I'll talk a bit more as the talk unfolds. Now, obviously, this perspective that science is in conflict with faith, or that science properly understood undermines belief in God, is very contrary to the perspective of the biblical writers. In Psalm 19, in the Tanakh, the Old Testament, the Hebrew Bible, we encounter the idea that the heavens are actually in some way declaring or revealing the glory and reality of God. You get the same idea in the New Testament. St. Paul talks about, in Romans 1, this famous passage, he says, "For since the creation of the world, God's invisible qualities, his eternal power and his divine nature," sometimes in the older translations of the Bible translated wisdom, "have been clearly seen, being understood from what has been made." In other words, if you look at nature, there's something about nature that not only affirms the reality of God, but actually reveals something about the qualities of the Creator, his power and his wisdom, his intelligence. Now, this is obviously a very different perspective than that of the New Atheists, and I suppose we shouldn't be too surprised that the Bible writers and the New Atheists disagree about what nature can tell us about the reality of God. But what might surprise you is that the New Atheist perspective on what science can tell us about the reality of God is diametrically opposed to the perspective of the founders of what we call modern science. Historians of science talk about a period of time from roughly 1300 to 1700. Others date it 1500 to 1700. They call it the scientific revolution. That's when science in its modern form as an organized form of inquiry and investigation of nature really got going. And when we think of that period of time, we think about the giants of the scientific revolution, like Johannes Kepler, the great astronomer. We think about Galileo. We think about Robert Boyle, the groundbreaking chemist. And we think about, for example, Sir Isaac Newton. Here's a front piece of one of the early works in biology, late 17th century, one of the kind of really cutting-edge pieces of biological research at that period of time. Notice the front piece, the introductory page here. It's a paraphrase of the book of Romans, that passage I just read, the wisdom of God manifested in the works of creation. There were a lot of them, so it was in two parts. It was two big volumes by John Ray, a fellow of the Royal Society, the first organized scientific society in the world. Ray, like many of the founders of science during this period of time, was a devout Christian who believed that by studying nature, he was learning about the wisdom of God. Now, the scientists at this period of time had two key concepts that historians of science have identified as crucial to the rise of modern science. One was the idea of order. And the idea there was that nature is an orderly system. They would talk about the concourse of nature, an orderly system. And it was orderly because it reflected the mind of God. God was a God of order, and he built order into the world. And therefore, we could perceive those patterns of order, which the early scientists called laws of nature. And they were laws because there was a lawgiver. It was a juridical, theological metaphor that suggested that the order of nature was a manifestation of the ongoing superintending by God of his power over nature. I talked last night in the interview with Eric about Newton's notion of the laws of nature. He thought that they were a manifestation of constant spirit action. It was the Spirit of God who imposed upon the brute matter an order that could be perceived by the scientists, which we describe mathematically as laws of nature. That was one key idea from this period of time. The other was the idea, perhaps even more profound, of intelligibility. To most of us without scientific training, nature can look very chaotic, hard to discern what's going on. But the early scientists had the conviction that if they studied nature carefully, that it would reveal its secrets. It was intelligible to them because we human beings are made in the image of God. God is a rational creator. He built rationality, order, and put design into nature. And because he built our minds as well in his image, we could perceive the rationality, the order, and the design that he built into the natural world. And so this made science possible, and it made this incredible flowering of organized science possible in Western Europe during this period of time in a decidedly Christian milieu, a period when most of the leading intellectuals had, if not a genuine faith, a Christian worldview. Now, this perspective reached an almost majestic quality in the writings of Sir Isaac Newton. I had an experience a couple years ago, several years ago now, where I was called to testify before a group called the United States Commission on Civil Rights. And they were investigating whether or not there was something called viewpoint discrimination in the teaching of biological origins. When I got the invitation to testify, my first thought was, well, I wouldn't have thought you needed a hearing to establish that. All you have to do is open any college or high school biology textbook, and there's only one perspective offered. It's the contemporary Darwinian perspective. And in the discussion or presentation of evolutionary theory, there is not in these textbooks even a discussion of some of the contemporary critiques of, for example, the creative power of the mutation selection mechanism, which many evolutionary biologists now doubt, but not a mention of that. So of course there's viewpoint discrimination. But in any case, the commissioners were interested in my perspective as a proponent of the theory of intelligent design. I came and gave a short testimony, and afterwards, one of the commissioners in the back row started asking kind of series of aggressive questions that I thought were meant to impeach my credibility. He was asking about where I did my PhD and what would my supervisors have thought of my perspective on ID, blah, blah, blah. But then he said, isn't your perspective, though, very similar to that of Johannes Kepler and Robert Boyle and Isaac Newton, some of the early founders of modern science? And when I heard the name of my heroes, my spirit brightened. And I began to talk a little bit about that. And then my opposite number at the hearing, who was there defending the Darwin-only approach to science education, interjected and said, well, what Dr. Meyer is saying is true. Sir Isaac Newton was a very religious man, she said. But he took great pains to keep his religious ideas about intelligent design, notice how she equated the two, out of his scientific work. And I'm not one of these people that memorizes poetry or even Bible verses very readily, but it happened that I had in my briefcase with me an essay that I'd finished just that week with a paragraph, a block quote from Isaac Newton, and it's the one that I have on the screen behind me, and I had it nearly committed to memory. And so I found myself saying something that sounded very impressive. I said, well, but actually that's not true. In the general scholium to the Principia, ... General scholium just means introduction, but she didn't know that, neither did the commissioners. And I quoted this pretty close to verbatim. Let me share it with you. This is Newton. He's talking about the solar system. He's presenting in the Principia his theory of universal gravitation. But knowing how this law now works, he's got it mathematically described, he's still amazed that the solar system is has all these stable planetary orbits, because he's aware of how there's this delicate balancing of all the gravitational forces. And this is what he says: though these bodies, the planets, may indeed continue in their orbits by the mere laws of gravity, yet they could by no means have at first derived the regular position of the orbits themselves from those laws. Thus, this most beautiful system of sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being, capital B. And as I finished paraphrasing, the commissioners in the back of the room, I saw several smiles break across faces like, oh, this could be a lot more interesting than we thought. I'm the young upstart, and here's the person speaking for the scientific establishment. Because whether or not the commissioners were persuaded of my views on intelligent design, they realized that as a matter of historical fact, the founders of modern science were very favorable to this idea, and they built it into their scientific work. It wasn't something they kept separate as a theological proposition. They thought science itself was pointing to the design of an intelligent and powerful being. Now, obviously, that's a very big shift in perspective from that of Richard Dawkins and Neil deGrasse Tyson and Bill Nye the Science Guy and all these popularizers we've been hearing about. So how did we get from Sir Isaac Newton to Richard Dawkins? That's a big intellectual shift. And there's a story to be told about this in intellectual history or scientific history, and it really begins in the 19th century, and there's a kind of a series of scientific ideas that come about that end up producing that worldview shift. In some ways, it starts with another physicist named Pierre Laplace. He, in Newton dies in 1727. The Principia is 1687. So about a century later, 1799, Laplace writes this book called The Celestial Mechanics. And in the Celestial Mechanics, he attempts to do what Newton in that previous quotation said you couldn't do, which was explain the origin of the solar system purely by reference to the law of gravity and some clustering of nebular gases. Newton thought it was a setup job. He thought it was finely tuned somehow, that God had designed the solar system. And Laplace tries to dispense with that idea. He's brought before Napoleon a few years later to receive commendation for this important book. And according to the story as it's told, Napoleon asks him, wonderful book, we're glad you showed up the British, but I know that Newton used to write a lot about God in his scientific works, but you don't. Why is that? And he is said to have puffed himself up and said, Sire, I have no need of that hypothesis. That was my French accent. Sorry about that part. This now is one of those things that historians of science debate about whether this conversation actually happened. Some say it's apocryphal, others not. Whatever is the case, it certainly captured the spirit of the age and the spirit of the coming age, especially in the 19th century. One by one, there were theories that came online that disputed the idea that there was any evidence of design in nature, and that instead purely undirected natural processes could explain all the origin of all the things we see around us. So we have this account of Laplace of the solar system. Then in geology, we have some very reasonable explanations, but relying on purely undirected, unguided processes to explain the origin of the mountain ranges and the canyons and the great geological features. And then in biology, we have, of course, Darwin's great theory, 1859, the origin of species. He attempts to explain the origin of all the new forms of life as a result of unguided, undirected processes, in particular natural selection acting on random variations. His idea is extended first he does it himself to explain the origin even of human beings in his book, The Descent of Man. And then other early evolutionary theorists, Ernst Haeckel and Thomas Henry Huxley, extend the idea in the other direction to account for the origin of the first cell from the simpler chemicals in what we now sometimes refer to as the prebiotic soup. And so by the end of the 19th century, you have this seamless, completely naturalistic, completely materialistic story from the origin back, very far back, to explain the origin of the solar system, to planet Earth, to the features on planet Earth, to the first life, to all the new forms of life, finally to human life. And so this is a completely materialistic account. And as a result of this, by the end of the 19th century, you don't just have a series of theories about origin, sorry for the rhyme, but you also have something like a comprehensive worldview developing. And scholars call this worldview scientific materialism. How many are familiar with the term worldview? Okay, that's really good. It's getting into wider currency. When I was in college, I was a physics and earth science major. I majored in both fields. And one of the reasons I did the science stuff was my dad was a mechanical engineer. When I went off to college, I knew I didn't want to be an engineer. Whenever he was fixing the engine in the car and he had me help, I'd drop the wrench in the most inaccessible place, and he'd go like, because I was thinking about other things. And so he said, before I went to college, he said, look, son, I know you don't want to be an engineer. You don't have to follow me in my footsteps. But before you choose a major, please take at least 2 years of college math, because if you don't have that math under your belt, you're going to be limited in what you can do. And I said, okay, sure, Dad. If I don't have to be an engineer, I'll do anything. I'll take the math. So I get done with the 2 years of college math, and about all you can major in at the liberal arts college where I was attending was physics. And physics was about as close to engineering as you could get in the college where I was, and I think my dad got what he wanted, so this is awesome. But I was always sneaking across campus to sign up for one philosophy class every year, because he heard in the interview last night I was always interested in these deep why questions. And one semester, I was taking a course called Atheistic Existentialism. It was my junior year, and it was all about Nietzsche and Sartre and Camus and the depressed, God is dead, atheistic existentialist writers. And anguish, forlornness, and despair, and I was doing really, really well at the despair part. And I got an A in this class, and the grade slip came home at Christmas time. We have this kind of Germanic work ethic thing in our family. Even as a college student, my dad is intercepting the report card. And so one night he says, I'd like to have a little chat. And we're sitting at dinner, and he says, he gets the grade slip out, and he starts reading the grades. And the first one is atheistic. And he says, atheistic, what in the blank? He says, is atheistic, existentialism, he says. And then he pauses for effect, and it reads it, and it says, A. Like that's a bad thing. And then the next grade is theoretical mechanics. And that was my most important physics class that term, and he reads it as B. And then he gives me this look like it is now time for offspring to give account of offspring's behavior. And I start getting really defensive, and I say, Dad, look, I know these philosophy classes don't mean anything to you, but they're important too, because that's where you learn about worldviews and about what people are thinking at that deep level, and everybody has a worldview. It's kind of like a personal philosophy, and it informs your perspective on other issues, and if you understand people's worldview, you can understand where they're coming from and why they use the terms they do. And he interrupts me, and he says, son, you don't need a worldview. You need a job. And now I'm one of those dads, so I get that now. And my dad, being a mechanical engineer, is actually now really excited about what we're doing on intelligent design, but it took a while. And anyway, the point is worldview is very important. It is a kind of, a good way of thinking of a worldview is it's a personal philosophy that everyone has, whether they know it or not. And worldviews answer some very fundamental questions about reality. Not questions like, what is the formula for salt, or who won the World Series, but deeper questions like, what is the thing or the entity or the process from which everything else comes? In fact, that's in people who write about worldview, they call that the prime reality question, the most important question. And the dominant worldview in our elite knowledge culture today is this worldview that I would just mention, called materialism, or sometimes called naturalism. The idea that nature is all there is. There's nothing beyond it. Nature made of matter and energy. And so if you're familiar scripturally with something like the prologue to the book of John, where it says, in the beginning was the Word, or from back to Genesis, in the beginning God said. There's the idea in the theistic worldview that what is the prime reality is a personal God with a mind with creative intentions who brings the universe into existence and then through his intellectual power shapes matter to create and generate all the things we see around us. The materialistic worldview, sort of the flip side of that John 9 prologue, says, from eternity past were the particles. There was no beginning. The thing that is eternal and self-existent is matter and energy. And that matter and energy arranged itself to become more complex stuff, more complex living stuff eventually. And the living stuff evolved by Darwinian processes to produce all the new forms of life we see, including one form of life, namely us, who conceived of the idea of God. And so you have God in the materialistic worldview, but only as a concept and only at the end of the process. In the theistic worldview, the whole thing is reversed. You start with God, then you get matter, and then you get all the wonderful things we see around us as a result of God's creativity. So these two worldviews are in a kind of ideological conflict, and the conflict between science and faith is not a conflict between scientific evidence and faith. It's really a conflict between these two worldviews, one of which claims to be based on science, but I'm going to suggest that maybe that's not actually the case. The bad news for people of faith is that this materialistic worldview really does dominate the culture now. The elite culture, the universities, many of the elite science research institutions, the law schools, the courts. Students who are of faith know this when they get to those places. They know they got to kind of keep quiet because their view is not the dominant view. But there's good news, and that's what I'd like to talk about this morning, and that is that the science of the 19th century that gave rise to this perspective has been eclipsed by major developments in science over the last 100 years in three main areas: cosmology, physics, and biology. Let me talk first about the cosmology or the astronomy. The shift in this field starts in the 1920s. There's a now famous astronomer named Edwin Hubble. Most of us have heard of him because of the famed Hubble telescope. It's kind of a bummer for him because he's a really great scientist. He got a telescope named after him, and it's always broken. And they have to go up there and fix it. But anyway, Hubble starts working in the 20s. He comes out of the field of law into astronomy at a really propitious time. They're building these great dome telescopes. This is the 100-inch diameter telescope at Mount Wilson that Hubble used. And using these great big telescopes, the astronomers are able to, at this time, to start resolving these onto photographic plates, the light coming from little tiny, distant, previously indistinct points of light in the night sky. And it turns out that these little indistinct points, once the light is collected over with a long exposure on a photographic plate through these big telescopic lenses, the light starts revealing structure. And this is a picture of what's called a Spindle Nebula. And there were others, spiral nebulas. And, that's a spiral. And here's another spiral nebula. Now, this reignited a debate that had been going on in astronomy between astronomers who thought that our Milky Way galaxy was the only galaxy, and other astronomers who thought that there were other galaxies beyond the Milky Way, island universes, if you will, beyond the Milky Way. And this was called the Great Debate in the 1920s. But in 1924, Hubble was able to settle this debate by using some new techniques for estimating distances. He was able to determine that the Andromeda Nebula was actually the Andromeda Galaxy, that it was a separate galaxy. And the way he was able to show that is he was using these new techniques for measuring distances. He determined that the Andromeda Galaxy, one of the closest ones to us, is 900,000 light years away. That was his estimate at the time. And the astronomers thought at the time the Milky Way was only 300,000 light years across. So clearly it had to be way beyond the Milky Way. Therefore, it was a separate galaxy, and the Andromeda Nebula, which just meant gas cloud, was renamed the Andromeda Galaxy. That was pretty awesome. And as they began to look at other points of light using these same techniques, they found that there were galaxies in every direction of the night sky. In fact, if you look at this little square that's highlighted on the PowerPoint, that's like a little tiny part of the visual field, maybe like a dime at arm's length. And now if we were to magnify that, it reveals galaxies galore in even the tiniest little quadrant of the night sky. And the current estimate is that there are about 200 billion galaxies in the visible universe. So in just the space of a decade, our sense of the immensity of the universe was just magnified incredibly. Now that was an amazing discovery, but even more important was what was discovered as a result of the light coming from these galaxies. Turns out that the light was redder than the scientists expected. You know how if you shine light through a prism and it separates into colors, the red through to the blue and the violet, and the red light has a long wavelength. And if an object is emitting light and moving away, it will cause the wavelength of the light to stretch out, and it will look redder than it would otherwise look. So the light coming from the gases in these faraway galaxies looked redder than similar light would look coming from if we looked at it in the spectra in a laboratory. And they call this the red shift. In other words, the wavelength was stretched out. It's kind of like the Doppler shift with sound. When if a train whistle goes by, it goes, the sound, well, that's the wavelength of the sound stretching out. The same thing happens with light. And so the scientists were able to discern that the galaxies are actually moving away from us. That's what the red shift meant. Now that had incredible implications for the question of the origin of the universe itself. Hubble used data from an unsung hero in astronomy named Vesto Slipher about this red shift. And so here's the implication of all this. If the galaxies are moving away from us in every direction, in the forward direction of time, the only way that could be true is if there is a kind of spherically symmetric expansion of the universe, that everything is expanding in the forward direction. So if we think of, I got a visual aid, in the forward direction of time, you have the universe getting bigger and bigger, and the galaxies, every galaxy getting further and further away from every other galaxy. But if you wind the time clock backwards, if you back extrapolate, and you think, well, what was the universe like 100 years ago, or 1,000 years ago, or 1,000,000 or 1,000,000,000, or however far back you go, eventually you get to the point where all that galactic material is going to congeal or would have come back to the same point, a point marking the beginning of the expansion of the universe, and arguably the beginning of the universe itself. And so we have, from observational astronomy, the first hint that the universe has not been here eternally. It's not eternal and self-existent, but rather it had a beginning. This is one of Hubble's plots showing that there was a law. The further out the galaxies are, the faster they're moving away. And that, again, can only be true if the universe is expanding in this spherically symmetric way. Now, about this time, actually a little before this time, there was a famous physicist with really bad hair who had come to a very similar conclusion, and this was Albert Einstein. He was in the 19-teens, still working in Germany. Eventually he came to Princeton to escape the Nazis. But in the teens, he came up with another theory, a new theory of gravity known as general relativity. And we talked a little bit about this last night, but it's basically the conceptual idea behind it is that matter causes space to bend, such that other matter passing through that space will have its motion changed by those preferred lines of trajectory. So as a result of this, he's thinking, well, if matter causes space to bend, then that means that if all you have in the universe is that gravitational field, then everything should be collapsed onto itself into something like a black hole. But we don't live in a universe like that. We live in a universe where there's massive bodies separated by empty space. So there must be some countervening force of expansion to offset the gravitational force, which means that the universe must be in some way dynamic. There's something pushing outward. But if something's pushing outward, then it would imply that there could have been a beginning. And that troubled Einstein. Because at this point in his career, it was different later, but at this point in his career, he was very much a scientific materialist. And so he posited something. It was kind of a fairly arbitrary conjecture on his part, but he proposed that this outward pushing force, which he called the cosmological constant, had exactly the right magnitude so that the outward push was exactly balanced by the gravitational pull, and you had a universe that was static, neither expanding nor contracting. It was kind of a contrived value that he assigned to this, but it worked to eliminate the idea of a beginning. And for a time, for him, that was a sigh of relief. But then in the 20s, other physicists started working with these equations, and they realized, that's pretty contrived, Einstein. That would be an incredible degree of fine-tuning to have that cosmological constant with exactly the value that you, Einstein, chose for it. The math allows a lot of other values that would imply, most other values would imply a dynamic universe. That's thing one. And then this amazing physicist, a Belgian Catholic priest named Father Lemaitre, is with Einstein at a conference in the 20s. And they're in a taxi cab ride going to the conference, and Lemaitre tells Einstein, first of all, your physics is contrived, the equations really suggest a dynamic universe, you know it and we know it, but also, have you heard about this redshift data that Hubble's working with out in California? Because it's showing that the dynamic expanding universe is really what the heavens have talked back, in effect. And Einstein listened to Lemaitre and eventually made his way out at Hubble's invitation to Pasadena, California, and had a peek for himself through the Hooker 100-inch telescope, and came out and announced to the media after seeing this in his heavy German accent. He came out and said, "I now see the necessity of a beginning." And later explained that the value, this arbitrary value he chose for the cosmological constant, was the greatest mistake of his scientific career, because he allowed his philosophical presuppositions, his predilections, to determine his scientific theory rather than letting the evidence decide the question. And anyway, it's a great moment in the history of science. It established what is now known as the Big Bang theory, when you have this convergence of theoretical physics, general relativity with observational astronomy, and that in turn established that the universe had a beginning. Now, Einstein was not the only scientist at the time who didn't like this. Sir Arthur Eddington, a famous British astrophysicist, said this. He said, "Philosophically, the notion of a beginning of the present order is repugnant to me. I should like to find a genuine loophole. I simply do not believe the present order of things started off with a bang. The expanding universe is preposterous. It leaves me cold," he said. This in psychology is known as the theory of denial. You notice what the evidence he's citing? He's not citing it. He says, philosophically, he doesn't like it. And later physicists, because you have to ask, well, what's the big deal? Why are physicists so upset about the idea of a beginning? Princeton physicist Robert Dicke put it this way. He said, an infinitely old universe would relieve us of the necessity of explaining the origin of matter at any finite time in the past. If matter itself comes into existence, then you can't invoke matter as the cause of the origin of the material universe. You need something that is immaterial, that transcends matter. And this conclusion was highlighted later in the 1960s by some work by Stephen Hawking. There's a bigger story here that I'm compressing, and maybe with Guillermo we can talk a bit more about it. After the Big Bang was proposed, there were some other models proposed, the steady state model, the oscillating universe model. These were each attempts to preserve an infinite universe that didn't have a beginning. But one by one, as more observations of different kinds came online in astronomy, these were set aside as inadequate theories. And then in the mid-60s, there was an extraordinary development in theoretical physics. Stephen Hawking, you probably know of him, wonderful, inspiring figure. The physicist confined to a wheelchair with the ALS disease. When he's working as a PhD student, he's working on black hole physics. And he's aware of the way that matter causes the space to curve. And he begins to and that's what he's thinking, okay, that's what's going on with the black hole. There's so much matter, it's curved so tightly, you can't get anything out. But he starts to apply this idea to the universe, and he's realizing that as the universe is going forward in time, matter's getting more and more dispersed. But as you wind that clock backwards again in your mind's eye, you eventually get to the point where the matter is so tightly curved, or the matter is so densely compact that space is getting tighter and tighter, more tightly curved in its curvature, and eventually the mathematics, something called the field equations of general relativity, which he and Roger Penrose solved, imply that there is an infinite curvature at some point in the finite past. Now, an infinite curvature corresponds to zero spatial volume, and then you have to ask what we discussed last night, how much stuff can you put in no space? And the answer is, well, no things go in no space. And so this singularity theorem has this profoundly anti-materialistic implication. And it happens that Hawking worked for much of the rest of his life to try to, as W.C. Fields put it, he was looking for a loophole. He was looking for a way around this conclusion. Hawking was a really interesting figure. He was a kind of theologically sensitive, even you could say God-obsessed atheist. And so he was aware of what he'd shown in 1968 with Penrose, but then he was developing other ideas, one called quantum cosmology, which we can discuss in the Q&A, and which I discuss at length in my new book, trying to find a way around this conclusion. But the straightforward application of general relativity to the origin of the universe implies a creation event. And we'll have a little quiz on these equations afterwards, but anyway, this is the idea. The curvature goes to an infinite, zero spatial volume. The astronomer Robert Jastrow said, this is an exceedingly strange development, unexpected by all but the theologians. He's writing in the 80s. And notice our starting point. Remember my starting point with Dawkins? He said that the universe is exactly as we should expect if there's nothing but blind, pitiless indifference. But these astronomers are saying, no, this is totally unexpected from a materialistic standpoint, but it was expected by the theologians. And Jastrow went on to say, for the scientist who's lived by his faith in the power of reason, the story ends like a bad dream. He's scaled the mountains of ignorance, he's about to conquer the highest peak, and as he pulls himself up over the final rock, he's greeted by a band of theologians who have been sitting there for centuries. Entirely expecting that the universe would have a beginning, because after all, in the biblical witness, you had the very first words are "in the beginning." Arno Penzias, one of the leading physicists who played a big role in this story in refuting what's called the steady state theory with his work on what's called the cosmic background radiation, put it this way. He said, "The best data we have concerning the Big Bang are exactly what I would have predicted had I nothing to go on but the 5 books of Moses, the Psalms, and the Bible as a whole." And indeed, it is rather striking. The first words of the Bible are "in the beginning." In the epistles in the New Testament, there are 2 different mentions of the plan of God existing before the beginning of time, which is really striking in light of relativity theory, because the singularity theorem implies that time itself is a created entity which has a beginning. And there's even mentions, 11 or 12 separate mentions in the Tanakh, the Hebrew Bible, of God stretching out the heavens, either having stretched or stretching out the heavens. So this new cosmology is in a way very much expected on this, from the standpoint of theism. It also helps revive an ancient argument for the existence of God that went like this. Everything that begins to exist must have a cause. The universe began to exist, and the universe, therefore, must have a cause separate from itself. All causes are separate from their effects. We call that transcendent or separate cause God. Now, I developed this argument in a little different way in my new book on the return of the God hypothesis, using a method of reasoning known as inference to the best explanation, where if you have an historical event, you try to explain it by reference to all the possible causes you could consider. And then you examine those causes to see which one are causally adequate or sufficient to explain the effect. And if you find causes that aren't sufficient, you one by one eliminate them. And in the best case, you elect that one cause which has the powers or is known to produce the effect in question. What I've done in the book is I apply this not to scientific hypotheses, but to the different worldview hypotheses with respect to the origin of the universe. I look at materialism, and materialism has this problem. If matter itself comes into existence a finite time ago in the past, then there's no matter before that to do the causing. It's an inadequate cause. It's not causally adequate. Pantheism has the same problem because it equates God and matter. It says that God is in all the material things around us. That's the Eastern philosophy. And God and matter are coextensive. So before there was matter, if the universe, the material universe, had a beginning, before that there was neither matter nor God. And so pantheism also lacks a cause separate from the universe that could bring it into existence. It lacks transcendence. Theism, on the other hand, posits a God that's independent of the universe and therefore can provide a causally adequate explanation for the origin of the universe from something else, because there is a something else. There's a transcendent entity of great power who could bring the universe into existence. It happens that deism also posits a transcendent entity, and as we talked about last night, the question between deism and theism would be, is there any evidence of design after the beginning of the universe? But both deism and theism could account for the origin of the universe in my reckoning. And so applying this method, we end up with something like this, a God hypothesis of some kind. Now, in my book, and Jay will talk a bit more about the fine-tuning, but there are always counter-arguments to good theistic arguments. And one of the ways you assess how good an argument is how well it sustains its strength in the face of counter-arguments or critique. And one of the big counter-arguments today against this cosmological argument that I'm developing is Hawking's new idea that he developed after the singularity theorem called quantum cosmology. And that's just the idea that that when the universe is very small, quantum physics can describe the universe in that early state, and those quantum laws would make our universe in some way expected. And he has a famous quotation from the last major book he published before he died, where he says, because there is a law such as gravity, and he's talking about a law of quantum gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists and why we exist. Now, there's a whole lot to say about this. I get into this in great detail in the new book, and we'll talk about it in the Q&A if you'd like as well. But you can see just from this quotation, there's a fundamental confusion underlying this whole enterprise. Hawking was a great physicist and a subpar philosopher. And this is just really bad philosophy. The laws of physics describe what matter and energy do in relation to each other once you have them. They don't describe where matter and energy come from. Okay, they describe what matter and energy do, what stuff does, but they don't explain where stuff came from. So this is what you call a category error, and it runs all the way through Hawking's work on quantum cosmology, as well as popularizers like Lawrence Krauss's. So we can talk more about that in the Q&A. I discuss all of this in my new book, The Return of the God Hypothesis. But I think you can see just in conclusion that Dawkins's bold assertion that the universe looks as we would expect from the standpoint of a materialistic worldview is patently false. It looks exactly as we would expect from a theistic point of view, and people have to come up with really abstract speculative cosmological ideas like quantum cosmology and multiverses to get around things like the fine-tuning and the evidence for a definite beginning to the universe. Thank you very much.